Hey, welcome back to lesson 5.6. Oh my goodness, we've done all these triangle congruence theorems, and we have a few more today. And vocab, congruent figures, we know what that means, same size, same shape. And rigid motion just means like you move something, but you keep the size, right? You're just basically changing location. So rigid motions are going to be translations, reflections, rotations, um, but not dilations. All right, two new ones today. Show both in the screen at once. We have angle, side, angle, which basically says, hey, if you go in order and you have an angle and a side, then an angle. And technically speaking, it would say the included side of two congruent triangles are congruent to the included side of two congruent angles. Then the two triangles are congruent. So angle, side, angle. And then we have angle, angle, side, which says if you go in order, you have two angles and then a side are congruent to two angles, then a side, then the two triangles are congruent. So all of the ones we have so far, I'm going to list them. We started with side, angle, side. Then we did side, 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 and we did the HL theorem. Now we have angle, side, angle, and then angle, angle, side. So these are the two new ones today. So we're going to end up with two proofs at the end of this lesson. Before we get to those proofs, let's go to the next page. And now we want to decide if there's enough information is given to prove the triangles are congruent. So which theorem? Again, I'm going to write those theorems up here because now we have a lot to pick from. We have side, 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 the HL theorem, side, angle, side, angle, and angle, angle, side. So these are all of our options. So we want to know about these two triangles. Now doesn't give us a congruent statement. So the order of the names they gave us doesn't matter. We just got to decide if the triangle is congruent. So let's look at what we have given. I'm also going to just write in that I have my reflexive property here. So I don't have side, side, side. I don't have the HL theorem. Side angle, nope, no side angle side here. Technically, we sort of do have the side angle side. If we put the reflexive property here, we could say the third angle theorem says these two are congruent, and you could have side angle side. But without adding extra stuff here, and I don't even have to use that reflexive property. It's just nice to throw in there. If we looked at just what was given, so I guess I'll erase that really quick. What I do see is I see angle, angle, side angle, angle side. So one arc mark, two arc marks congruent side, one arc mark, two arc marks congruent side. So I do see angle, angle, side without adding anything else to this, okay? But if I threw in that reflexive property, there's more than one way to prove these triangles are congruent. Number two, I see one arc mark, side, two arc marks. One arc mark, side, two arc marks. So I see angle, side, angle. Angle, side, angle. Number three, JKL. I'm actually going to highlight this really quick. J to K to L is this one right here. And then I want to say, is it congruent to this one right here? So the bigger ones. Um, so do we have enough information here? And if I look, I have the reflexive side here, which is right here, a part that's reflexive. But the problem is I don't know anything about this side or this side. I don't know anything about these other angles. Just so happens that there's not enough information on number three. So I can't prove that one. I just don't have enough information, unfortunately. And then number four, it looks like you could maybe try to use hypotenuse leg theorem. But the problem is I only know the hypotenuse. I don't know a leg. But being that this is a right angle, I could use the definition of right angle, say this is 90 degrees. So then these are congruent. I have angle, angle, side, angle, angle, side. So I do have angle, angle, side for number four. Let's look at 5 and 6. Decide whether you can use the given information to prove these two triangles are congruent. So based on we know, this is trying to show angle, angle, and then a side. Now, remember, I want to talk about angle, angle, side. If we needed to, we could draw this, and maybe that'd be helpful here. I can say L, M, N, and this. I'm not purposely drawing them to look like a right triangle. I'm just drawing triangles. P, Q, R, the same order. It says M is congruent to Q. N is congruent to R, and the NL is congruent to RP. Do I see angle, angle, side? I do, so I can say angle, angle, side. It matches. I'm drawing the triangles in the same order, letter-wise. So here, again, I'm going to do L, M, N, and then P, Q, R. And let's just actually mark these again. It says L and R are congruent. Whoa, whoa, whoa. L is supposed to be congruent to P. And this says M is congruent to Q, which does match up here. So I'm going to say no. The problem here is we don't have the right angles showing up. Like L doesn't pair with R. It's supposed to pair with Q. So no, we don't have enough information. Okay. All right. Proofs. This one's not bad. We have a given here. It says, prove the triangles are congruent using angle, side, angle. So I know the very, very last line should be the two triangles are congruent using angle, side, angle. I want to get to the stuff leading up to it. Given. I'm going to write my given here. My given is that AC bisects angle DAB and angle DCB, and that's a given. So what does that mean? When you bisect something, I'm going to go up here. If AC bisects that, that means I'm going to create two congruent angles. So now I created two up there, but at the bottom, if I look at DCB, which is a really big angle, that means these two angles are going to be congruent. So that's my definition of bisector. So what I can do here is I can say angle BAC is congruent to angle DAC, and angle BCA is congruent to angle DCA. And that is from the definition of a bisector. Also, I can spell right, of a bisector, right? Now I can say that AC is congruent to itself. I'm going to zoom up here now. So my third thing is I might say AC is congruent to AC because of the reflexive property. Now I'm not using the symmetric property. So maybe instead of saying AC is congruent to AC, um, I should say something like AC is congruent to CA. I'm not really worried about that. That side is congruent. Now, what I can see though in the diagrams, I can see, let me move this down back here again. I can see angle, side, angle, angle, side, angle. So now we have that we have triangle ABC is congruent. I don't know why I put a line on top. That's silly. It's congruent to triangle ADC, and that is going to be from the angle side angle theorem. All right, last one. Here we go. Proving that the two triangles are congruent, but now we have a circle here. And oh my goodness, we don't have a lot in the given. Let's start with the given here. The first thing is O is the center, and angle N is congruent to angle P. Now that's all given here. It's in the diagram too, so this is our given. Now, O is the center. So what we can know is because of it being a radius, or you can say that all points are equidistant the center of a circle. And what that means is I can say ON, OQ, OP, and OM, those are all congruent to each other. All right, so OM is congruent to OQ, which is congruent to OM, which is congruent to OP. They're all congruent to each other. Now, if I look at any of these, I see two sides of a triangle that are congruent, which means this is an isosceles triangle. So the base angle theorem says the two angles are supposed to be congruent down here. So I can say angle ONM is congruent to angle OP. MN. And I can also say angle OQP is congruent to angle OPQ, and that's going to be our base angle theorem. So I'm going to mark these. Now they're already congruent. Now that I see that, I see angle, angle, side. Angle, angle, side. That's what we're trying to prove here. So my last step is going to be triangle MNO is congruent to triangle PQO, and that is from the angle, angle, side theorem. All right, there's our note. Any questions, as always, reach out. If not, we'll see you in class or the next video. Have a wonderful rest of your day.